Good afternoon and welcome to the latest in the Verimed webinar series. Today we've got James Diserens presenting on turning fantasy into reality, creating custom data visualizations for future reporting. So James joined Verimed in November 2016. Originally having graduated with a BSc in physics, he started work as a SAS programmer in 2014, working on phase 1 clinical trials, before joining Verimed to work as a programmer to continue developing his technical and statistical skills. So if you haven't joined a Verimed webinar before, you'll know that you're automatically on mute. If you do need to ask me or James anything throughout the session, you can do so on your questions, in your questions box on the GoToWebinar toolbar, which is on the right-hand side of your screen. James will present for around 30 minutes today, and we'll have a question and answer session at the end. And you can type your question for James into the questions box again on your toolbar, and I'll be presenting those to him at the end of the session. The slides and a recording of the webinar will be available to you after the session, and the recording will also be available on our YouTube channel as well. So without any further ado, I'll pass you over to James. Thanks, James.
Thanks, Louise. Welcome, everybody. So this is actually a talk that I gave at the PhUSE EU Connect conference in Frankfurt last year. So alongside the slides, there's also a paper, and in that paper I kind of outline and show all of the code that I talk about today. Most of it's macro code, but that is going to be available alongside the recording of this webinar, and is also available through the PhUSE website. What I'm going to talk about today is a little bit about my experiences in working with data visualizations, graphs, in particular, comparing how we use graphs in study reporting against how we might use graphs in other exploratory or post hoc analysis. The differences between those. I'm going to talk a little bit about SAS graphics, obviously a little bit of comparison with R when you talk about SAS graphics, a section on graph template language, and then I'm going to go into some examples of some template code that I have written macros for that we use at Verimed. So there are some embedded line plots, lattice scatters, and swimmer plots. Obviously, with this kind of code, there is several ways to do things, so it's not, definitive. This is just a method that I've come across that I wanted to use, and I think it's particularly helpful. So to start out, talking a little bit about data visualizations. I think it may seem slightly obvious, but it is useful to talk about what is the point in including graphs in our study reports, or in fact, producing graphs at all. So graphs are great for allowing us to communicate a large amount of data and get that across relatively quickly in a small area or small time. And also, they're a much better way for communicating numerical data. In terms of the way the human brain works, we're much better at understanding things when we can see a visual representation rather than just numbers on a page. And that's a great way to communicate a story to others, to show an overview of data, and so very useful to provide alongside tables as an overview. As it says, picture is worth 1,000 words. So, study reporting. From my experiences, I found that graphs tend to be underused in study reporting. There's little requirement for what we have to include when we submit data in terms of graphs, whereas tables and listings are fairly rigid. We know exactly what we have to provide. So alongside that, there's actually little guidance about how we should present certain types of data in figures. And we still have to provide an analysis plan, shells, which should be written before we start to look into the data. So it's kind of quite rigid on what we're able to do. So this kind of limits what a lot of people provide in terms of figures. It's understandable that you're going to be conservative when producing an analysis plan. You're not going to go out and develop, stick something new in if you haven't really tried it. Therefore, it's quite common that you're going to end up with just producing the same figures again and again and again. And actually, there might be a better way of doing things, or something new that could be introduced that is going to provide a much better overview of the data that we have. And then we compare that to what we do with exploratory, ad hoc, post hoc analysis. And really, it's a growing difference between the two. There's a lot more interactive software that's becoming available in the last 10 years, stuff that allows greater flexibility and much more freedom in how we present the data in graphics. You look at something like Spotfire, R-shiny, you've got great tools there for developing figures that data can be uploaded to and provided to a clinician, a sponsor, who can then drill down into the data and really work out what's going on. Whereas other tools that we previously might use, Excel for some very quick graphs, you just want to get an impression of what's going on, or SAS, where currently seem quite limited, quite restrictive in what we're actually providing. And unfortunately, as quite a lot of people might say, a lot of the programming frameworks that we work in for producing reports, 99% of the time that is still going to be in SAS. So we are required usually to use SAS for these kind of things. Obviously brings it to the elephant in the room, which is the great debate, R versus SAS. What are we able to do in graphs with R SAS? Well, typically you might hear this comment, R is better than SAS for graphs, and then people go away, might say, oh, well, we could do that in R. It's all very helpful, but sometimes you need to do it in SAS. I'm not particularly interested in the debate of what is better, R or SAS. So they're tools that we use. Sometimes R is better. Sometimes if you're working with the rest of your data in SAS, that obviously becomes a better way to produce your graphs. But does this attitude of R being better than SAS limit what we do in SAS? Do we just try and head to R at every opportunity? Maybe there's a less awareness of what we're actually able to do in SAS as the later versions come out with more advanced graphics options. Typically, this has been true. SAS has been functional with graphs, but it's been quite difficult to customize. And SAS does require additional software for certain elements. Graphical elements are becoming more common nowadays in standard SAS software, but that has really been in contrast to R, which obviously is open source code and has enabled a lot more people to develop graphs and share code that can develop good graphs. And as I said, it's a crossover of skills. Really, as programmers, we need to be able to produce stuff in both R and SAS, and then we can use whichever is most appropriate for the data or what we're trying to do in that situation. So talking about graphs in SAS, there is the standard procedures. So this is your SG plot, SG panel, and these are quite useful. there's 16 different standards that you can produce. However, they are quite inflexible, hard to customize. So it's simple to get to a basic output that might be close to what we want to produce, and then you're going to spend a lot of time attempting to fiddle with your code and attempting to produce the output you actually want, and might not be able to get there at all. But more relatively recently, there's been advances with graph template language in SAS, and this is alongside ODS graphics. So this is code that might be prop template, which is much more flexible. However, it is quite complicated. It's more fiddly and can be quite daunting when you first look at it to know where everything's going on. It's less logically laid out than sgplot. And what this does is it produces graphs as a standard image. The advantage we have though is that sgplot and sgpanel are developed within prop template, so they're calling back a standard template. And we're able to use sgplot to create our prop template code, which gives us a great starting point for developing much more customized graphs. So let's take an example of a simple plot, something like a PK concentration time graph. So in sgplot, it might look like this. You've got an X variable, Y variable, your concentration, and we grouped it by subject. And this is going to produce a graph. It's going to look something like this. Fairly basic example. And now if we introduce this tmpl out, what we have is exactly the same graph. And now we're saving a file. In this case, it's pk.sas, which contains the prop template code. So we now have a file which contains code that can develop much more customizable graphs. And here is the prop template associated with that sgplot. It looks a lot more complicated. It looks like there's a lot more going on. But this is going to produce exactly the same graph. And then to produce that output from your prop template, uses proc sgrender. In this case, I've used ODS to write out to a PDF. And here is your output. Exactly the same. Only differences are the ODS and PDF elements. The other advantage here is we now have a template, and we can actually reuse that over and over again with different data sets, different where clauses, just by using the sgrender. So now I'm going to talk about some of the examples that I've used, graphs I've developed. And I think these are kind of things we want to be using when thinking about study reporting. So these were developed by speaking to senior statisticians and kind of discussing what they would like to be able to include in an analysis plan, and understanding what plots they think would be useful. And then I've gone away and developed some template code that I can save within a graphics catalog, and so that anyone else can come along, they can access this macro, and they can then implement that. So that you can get exactly what you want set up. So it takes a bit of foresight to plan ahead, but if you're able to do this, it's a huge advantage. So the first example is this embedded line graph. And I'm going to use a very, very simple, probably slightly exaggerated PK plot for this, where the issues here are really that you have a large amount of your data condensed into quite a small area of your graph. PK is quite common because the concentration levels between early time points and late time points can have quite high variation and you've got a large number of data points very early on in your profile. So there might be 80% of your points happen in the first 24 hours, and they're all condensed into the first 10–20% of this graph. This is going to make it very difficult to distinguish difference between two plots or two lines, which could be different subjects, could be different treatment groups, or a different application of treatment. But it's very hard to see what's going on here. Another issue is you have huge amounts of white space within this graph, and it's one of the first things you're told when producing graphs is that the data point should really be covering more than 50% of the area. So how do we get around this? Well, an option is to focus onto a smaller scale of the PK plot, maybe the first 24 hours, or in this example, I'm going to look at the first 8 hours. But you still want to maintain that overall picture to see the full PK profile. So we're going to try and embed a smaller section of the graph within that white space in the top right corner. And to do this, I've used a combination of SGplot and prop template. If you needed to, you could do this twice with prop template. It was just not necessary in this example. So first thing we have is the ODS graphics that allow us to save our image from our first graph. So this prop SGplot is going to be from 0 to 8 hours. We then go down to our prop template. Get back. First thing we're doing here is setting up our styles. Then we go down to the stat graph here. First step is to lay out the axis. So you set up the axis first, and then the series plot, which introduces your points into your graph and draws your line. So the key point for getting the embed here is that after that we have this draw image option. So this enables us to reinsert a previous graphical output back into our main graph, and we can anchor it. We can set the sizes that we want and fit this within our line that we have in our original graph. So this is the key bit of code for this graph, is the draw image. You see it's quite simple there, it's just one line of code really. And then to produce our overall plot, we call back that prop template with sgrender, and this is our output. And so now what we have is a PK plot. We can both see the overall picture and investigate what's going on in the first 8 hours of our PK profile. Second example that I had is was a request for a graph that could show multiple scatter plots alongside each other for comparison, or to see the relationship between various elements. So this might be between different subjects. My example is going to be the relationship between multiple vital signs tests or parameters. So the request was to have 5 different parameters: blood pressure, pulse pressure, heart rate, and to draw them in this kind of grid against each other. Now you can almost get there without using prop template. Use sgscatter, you get this output, which is a good starting point, but again there's some issues with this. On each combination of points, say systolic blood pressure versus diastolic blood pressure, the same graph is almost produced twice, in this cell here and this cell here, but the axes are flipped. So what you end up having is a slightly inverted plot, which is just adding noise and confusion. It's quite hard to really see the relationship with both of those plots. Another issue here is the axes. You're on different scales for each plot, and the labeling is a little bit all over the place as it switches from side to side. So say over here on the left, so over on the right. And again, if we look at it, the data that we're actually interested in is condensed into this bottom left third of the graph, and actually you're wasting quite a lot of space. So all that really serves to do is actually reduce the clarity of your figure. And as I spoke about at the start, what we're trying to do is give a quite clear, simple overview of the data so that anything that's going on can be investigated quite easily. So how do we improve that? Plot each combination just once, have a consistent axis, and increase that area of the plot that you've used. So now using prop template, I'm going to create a blank n by n grid. And this prop template code is actually quite easy to produce using that tmpl out option. So that gives you a basis to start. That would give you a n by n grid that you wanted. I then adapted that to be a macro where I can put in any number n for a number of variables to produce this. So this layout lattice sets up a grid of squares. So in this example, I've got 5 variables, so I'm going to want 4 columns and 4 rows. So that's what this sets up. Next step is to set up the axis within each section. So to do this, we're using the row axis, column axis option, and producing 1 to 4 rows across and columns. Set up a blank axis that we can then draw our scatter plot into. We then create each individual plot using layout overlay and draw a blank plot into any area that's not going to be used. So in that original lattice, it was 4 in the first row, 3 in the second row, 2, then 1. And this might look quite complicated, but it's a loop that's been developed up from just simply doing this in repeat 4 times and then working out how to break that down into more macro-friendly code. So in this example, the graphs are just being drawn by the layout overlay and scatter plot, so that's very simple to draw each individual graph. And then we're looping through so that we produce 1 plot in the first row, then 2 in the second row, then 3, then 4. And again, this layout overlay down here with the entry and just blank character allows you to produce a blank square within your plot. And this is what we come out with. So in that loop, we go through, this is the first. Then we produce 3 blanks across the row, and then we go on to the second row, 2 and 2 blanks, and so on. So now we've got each combination plotted just once. We have consistent axes, so we can compare what might be slightly higher, what might be slightly lower. And we're using a much larger area of the page for our graph, which is definitely an advantage. Makes it clearer to see where all the data points are. So the last example is a swimmer plot. This is a slightly more unusual plot, something I only recently came across and was a little bit different to kind of work out what was going on in the background. It's something that's quite common for something like an oncology study or for presenting something like adverse events, it's starting to be looked into how can we use this to present adverse events over time for different subjects. What we have is like timelines for each subject showing events and responses to events, and it allows us to see relationships between events and outcomes. In this example, we're plotting timelines of subjects. We're showing prior therapies, study treatment, best response, and we might also include adverse events. There's also randomization on here. So you're overlaying these individual events like treatment and surgery on top of your timelines. So rather than this being code that is developed within prop template, the important stuff for a swim plot is actually pre-processing your data. So you're converting all of your dates into relative days from a certain point, and for your bars or your timelines, you're introducing a start and an end date. And your reference point might be something obvious like dosing date, it could be a randomization date, or it's just the first date that you want to be displayed on the graph. So here we have time from 0 up to and we have our treatment and our best supportive care in this case. And I've actually done this just using SGplot, didn't need to use prop template. There's certain elements to this that come in, and actually it's broken down into a combination of 7 or 8 different graphs. So the first thing that's made is our high-low, which is our treatment on this case. So we're going to show for each subject start date and end date. I'm going to plot that and set up a bar for it. So that's how you plot the bars and lines. And then we're setting up our axis within the first plot. And from every plot thereon, we don't need to define an axis. We then mark on individual events using scatter, where again, Y is the subject and X is the time or the day. And a new element here is that we're now naming the legend for each individual plot. And that's the name to save the legend and a label to use within the legend. Then we can use a key legend statement at the end, allowing us to call back and insert legends at the bottom with multiple different plots included in one place. And here we can put a position, a title, and the number to go across. Now, if we wanted to start customizing this a bit more, we might have to go into prop template. But for this simple level, SGplot works. And again, here's the output. So, in summary, kind of what we have is improvements in SAS in stuff like graphical template language. It makes it much easier for us to customize SAS graphs. It gives great flexibility, but it's code that might not be as well known. Maybe people will default to SGplot or go away and try and produce stuff in R because they believe that R is better. And that gives us much more potential for what we can include in study reporting. The options are there, but perhaps not risking using them, or don't have the time to be prepared to use them. But if we have got ourselves organised in advance and created templates, set up a graphics catalogue, these things are quite easy for us to insert within our analysis plans and enter.
Thanks very much, James. sorry about that. I think the sound just dropped out. So we got the end of your session, but I'm hoping that people can still hear us now. If you can't hear us, then do type into the questions box and let us know. James, we've had one question come in whilst you've been presenting, and if anyone has any further questions they'd like to ask him, please do so by typing into your questions box that is located on your GoToWebinar toolbar. So James, the first question, do you think it's really necessary to be producing more complex figures for study reporting? Are the current tried and tested methods not suitable?
Well, I suppose it's that what we're currently doing is perfectly fine, but as I kind of mentioned at the start, what we're trying to do with figures is sort of giving an overview to represent the data so people can quickly spot trends or something that's happening within the data, and then know where to look within tables to really investigate the data a bit more. And there's no reason why these things are necessary, but I think it's much nicer to see this, to be able to quickly see these things, and I think it improves the quality of what we're providing to the regulators, rather than just trying to provide bare minimum of what they need. It's trying to help them understand what's going on, or help anyone who's coming in to look at the study really understand what's happening within the data.
Okay, thank you. Just following on from that, somebody's asked, have you had any formatting requirements that you weren't able to meet with this approach?
There's nothing that really springs to mind, no, other than perhaps a little bit of problems with trying to implement some ODS styles within sort of client frameworks. No, I haven't really.
Okay, great. Thanks, James. So I think that brings us to the end of our session. We haven't received any further questions. So just to let you know that you'll be receiving a feedback survey at the end of the session and in a follow-up email. We'd really appreciate if you could complete that just so we can continue to provide useful content to you in these webinars. As I said before, we'll also be sharing the slides and the recording as well. So without any further ado, we'll leave you to your afternoons. Thank you very much.